This example focuses on redistributing OSPF v3 into EIGRP for IPv6. So our overall goal here is to now take that those OSPF v3 routes and import them into the EIGRP for IPv6 process. So we are entering EIGRP for IPv6 configuration mode, and we are specifying the redistribute command. We are specifying the protocol we want to import routes from, OSPF in this case, and the process ID. So you're not specifying in this example OSPF v3 or OSPF for IPv6. You're simply specifying the OSPF protocol and then the process ID. And then that will make the connection. Now you might be asking, well, what if I have the same process ID for OSPF v2 and OSPF v3? That's okay, because we are in router configuration mode for EIGRP for IPv6. It can't import IPv4 routes. It can only import IPv6 routes. So it's looking for an IPv6 routing protocol. It's not going to look for an OSPF routing protocol. Remember, it's pulling the routes from the routing table anyways. So are we going to find IPv4 routes in our IPv6 routing table? No, we only see IPv6 routes. Match. Just like we saw with EIGRP for IPv4, we can match specific OSPF routes. We can match internal, external, intra-area, inter-area. We have to specify a metric. And realize the metric's still the same. That hasn't changed. Bandwidth, delay, reliability, load, MTU. That order. And just because we're using IPv6 doesn't mean the metrics change. The interface is still the interface. The bandwidth is still bandwidth. That hasn't changed. So nothing new to learn there. From IPv4, we understand that concept. We can also apply a route map, as we'll see in a future discussion, to granularly control specific routes that are being redistributed. Big difference. Big difference. The include connected keyword. What does that do? That ensures that the directly connected interfaces of the router performing redistribution will be included in the redistribution process, but only if those interfaces are participating in that routing process. Because by default, it won't redistribute those. So let's look at an example of redistributing those OSPF v3 routes into our EIGRP for IPv6 autonomous system. This redistribution will perform on R3. Let's go to R3 right now. Show IPv6 routes OSPF. We need to know OSPF v3 routes in order to redistribute them. So we're just going to focus on one particular network in this overall process, but we're going to redistribute all of them. And that one network is going to be the 2001 AA7:/64. That is the network hanging off of R7. And we can see that right here. So we do know about that. So we'll use R1 for verification purposes in our example. Show IPv6 route. In this case, we only know about directly connected routes in this EIGRP learned route, which is from the route of the network between R2 and R3. Let's go back to R3. Configure terminal. Router. IPv6 router. EIGRP 100. Redistribute. OSPF. Process ID is 1 in our example. And we're going to specify our metric. And I'm going to give you the example of 11111, just so you can see how it's going to be calculated. And we're going to go ahead and hit enter. we go back to R1 now and issue the show IPv6 route command, we can see an external network, the default route. We can see 5, 6, and there's the one we said we were going to focus on. 7://64 off of R7. So we've learned about it. The redistribution process was successful, but you have to specify the metric parameter. If you don't, redistribution will not occur. And notice, since we specified the values of 1, 1, 1, 1, 1, notice what the metric calculation ended up with. Let's see, what is that? 3, that's 2.5 billion is our metric in this case. It's relatively high, but it doesn't really matter. It doesn't really matter. It could be 4. It could be 1. It could be 2.5 billion. In this case, it doesn't matter. But if you have multiple redistribution points, it might become an issue if you don't specify accurate metrics or appropriate metrics. So you have to do the calculations. You're going to have to figure out what is most appropriate for your environment to make sure it's working as you intend it to, and the routes or the destination router, that boundary router, is the correct one that is being used as the exit point out of the EIGRP autonomous system. So we can see it learned all the other ones as well. However, what is missing? I believe if we look very, very closely, we will not see the 34://64 network, the network between R3 and R4. Even though it's in the OSPF domain, it's not being redistributed because it is directly connected to that boundary router. And I don't see it listed here at all. I see 46, 57, 67, 4, 5, 6. Yeah, 5, 6, and 7. So how do we make sure that one is being redistributed as well? Well, it's directly connected. So with IPv6, we need what? The include connected keyword, which is not like IPv4 as we discussed earlier. With IPv4, directly connected interfaces participating in the routing process are redistributed. IPv6 doesn't work that way. So we type in include connected, we go back to R1, and we should see 34::/ now, and we do. So let's recap on R3. Specifically, you have to define a metric. You have to. If you don't define a metric, routes will not be redistributed into EIGRP. Because there is no the seed metric is infinity for EIGRP. And the include connected keyword is not mandatory. However, if you want the connected interfaces participating in the routing process to be redistributed as well on that boundary router, you need that keyword.